Mrs. Sparks.
Chapter 5, you said too?
I'm gonna mute myself.
Oh, your microphone is muted now if you're asking me a question. It's still muted. It's at the very top of the screen. There you go. I can hear you. I think. Do you have a question? Oh, hello, Evan. I see you in the chat bar. And Alec, if you want to talk in the chat bar, you can, you scroll over. Hey, you got it. Good job. I'm a little late today because I had some internet problems when I loaded the Chromebook. So sorry about that.
My bad Wi-Fi is killing me.
And I'm also trying to screen share something new. Hang on. I was trying to screen share the book, but I can't write on it. Crap. So I've got to figure out how I can write on the screen. Let me see if it'll load in Cami.
My Wi-Fi is terrible.
Not working. But did you have a question?
Yeah, it's just really easy though.
Okay.
On 5 through 8, are we supposed to write the actual answer then the approximate, or are we just supposed to write the approximate?
Oh, just write the approximate.
Thanks.
Not a problem at all. Just trying to make sure that the primary reason for these is making sure that students understand when one thing is closer to, something than another. So learning how to estimate when it comes to square roots, because like a lot of times we're good at estimating when it's fractions or decimals and that kind of thing, but actually learning to estimate when something is a square root is really important as well, especially when graphing later on.
Okay.
So that's the reason. Sometimes it helps to know the reason behind an exercise to know what you're doing.
Yes.
See, that would be on the next page. Hang on just a second. I'm just confirming. Yes. Right there. Those. Can you see them on my screen or no?
Yeah, I can see them.
Okay, cool. So those are the ones that you were asking about?
Yes, ma'am.
Okay. Yeah, that's really what that's the purpose in my doing it.
Okay.
I know everybody can use a calculator to do it. So just figuring out which one it's closer to.
Okay.
So, with regard to that, like on number 5, the square root of 32 would fall in between, 25 and 36. you know, the square roots of those two numbers. So it falls somewhere between 5 and 6. And what did that one end up being closer to? Seems like it would be closer to 36, was it? Oh, Wi-Fi crashed. Okay. Oh, Alec left the chat group because his Wi-Fi crashed. Evan, would you like me to start back from the guided practice on the first page and go through those with you? Okay. How about approximating? Oh, no problem. How about approximating the square roots to the nearest integer on the ones that Alec was just talking about? Okay. So basically at the top, I'm going to go away from the chat screen for just a minute, and then I'll come back to see if you have any questions. So kind of like when you're looking over this part of the page where it's showing the square roots, the perfect squares in between, like when it showed 945, it's not a perfect square root. So it's showing the two places where the perfect square root is. So you're figuring those out. And here it just took the average of the two. I don't know if that's making sense. Hold on, let me see if you have any questions. Kind of flip back to that. I need to figure out how to split my screen. So like I was talking to him about on number 5, it's asking for the square root of 32. So the perfect squares near it are 25 and 36, because 5 squared is 25 and 6 squared is 36. So in between there, so you could say, 5.5 is probably, closer to that. The other thing that you can do is actually take the square root on your calculator by doing second square root 32 and then hit enter. And it says it's 5.65. So it's actually, because the decimal is 5.65, it's closer to 6 than it was to 5. But you could actually approximate the square root by saying 5.5. I don't know if does that make sense to you? Because what you're doing is taking the average of the two closest perfect squares. So I can look at number 6, and 10 squared is 100, and 11 squared is 121. So I can really almost honestly say, because 103 is so close to 100 and so far away from 121, the square root is much closer to being the square root of 10. Does that make sense? Okay, good. Now on number 7, we've got a couple things going on here. So what you want to do is deal with the negative portion that's on the outside of the square root first. You want to deal with that last. You want to deal with the actual square root first. So inside the square root, you have 48. And I know the perfect square of 7 is 49. And the perfect square of 6 is 36. But 48 is much closer to 49 than it is 36. So a better estimate is going for the actual square root part is 7. So then I'm going to say, well, it's closer to 7. So because of the negative on the outside of the square root, then I'm going to say the approximate square root of this is going to be -7. Does that make sense? Okay, good. All right, taking a look at 350 on the end there. We could handle that a couple different ways. Knowing some of your square roots is kind of important. Like the square root of, or the square of 15 is 225. So we're even higher than that. The square of 20 is 400. So we're not quite that high. So we're definitely between 15 and 20. Let's see what this square root of 350 actually is. Second, if you have your calculator, do you have your calculator with you? Okay, it says here it's 18.7. So that means it's going to be a little closer to 19 than it is 18. So we could actually take a look at 18 squared, which is 324. And then 19 squared is 361. So it is a little closer to that. So you're just kind of trying to take approximate. So we would say that we could actually say that the approximation here would be roughly 18 and a half, or we could say 19, and then you apply the negative to it, which would make it a -19. So it's approximate. So a -19, because it's a little closer to that end. So you can either use the calculator to find out what the exact decimal is, and then estimate up, like on that one. Let me redo that one. Do you have your calculator? Okay. Hit second. Do you know what button that one is? And then it's the square root symbol is the one above the x squared. So your little square root should show up in your window, and then type 350 and then hit enter. Did you get 18.708 and then a whole bunch of numbers? Okay, cool. So that way you would estimate. So 18.7 is closer to 19 than it is 18. And then you apply the negative to it. Or you can just actually take, if you know the square roots, kind of like with the smaller numbers, like 32, 148, you can estimate those by taking the average of the two numbers that they fall in between. Either way is fine. But you were good on the previous page for just the square roots, right? This part was a little more, I think, a little more confusing. All right, hold on just a second. Let me look at something. And then it looks like we had one other problem to do, which was number 9 on this next page. Let's take a look at that together. Oh, we're putting all of these in order. And so for that, let's just do that together. I wish I had a way to write on the screen for this. So for that, you would just actually take the value of each one of these and find the decimals, because it's easier to order decimals than it is like fractions or square roots or any of that. And it's a more precise measurement. So you would use your calculator to find each individual value of each of the numbers and then put them in order. So obviously, okay, so then so what you do to find the value of -9/2 is you take -9 divided by 2, and that should give you -4.5. So write that down. So that would be, I'm just going to put these, I'm going to go ahead and put them in the chat window since I'm not writing anything on the screen. And then we've got 5.2. We don't really have to do anything to that. And then we've got 0. We don't have to do anything to that. And then you want to take the square root of 7. So you're going to do second square root 7, enter. And that gives us a value of 2.6457. So I'm just going to round that. That value was 2.6457. So I'm going to actually round that to 2.646 for the most precise measurement I can on that. Do you understand where I get 2.646? I used the 7 to round the 5 up to 6. Okay, good. And now the next one is 4.1, so I don't have to do anything to that. So far, I'm going to type in all the numbers once I get them. And then now I've got a negative. So this is what I'm actually writing in my calculator, negative. Do you know where the negative button is on your calculator? It's right next to it's 0 dot, and then there's a negative in parentheses. So negative second square root 20, enter. And that gives me a -4.472. Let me write that down. So all of my numbers are -4.5, 5.2, making sure I type all these right, 0, 2.646, 4.1, -4.472. Those should be all my numbers. Okay, there's 1, 2, 3, 4, 5, 6. All right, so looking at those numbers, which there's looking like at the second set, and because I typed things 2 in a row, so that looks like that -4.472 is repeated. But looking at all of those numbers, if we're putting them in order from least to greatest, which would you say is the smallest number in that order? Remembering that if you're going in a negative direction, the larger the negative number is, the smaller the number is, the less value it has. So it kind of goes in the next direction. Which one would you say out of those has the smallest value? Yes, absolutely. It is -4.5. Perfect. Okay, so that's going to be the first one. which was the negative 9/2. So you can either write negative 4.5 or you can write 9/2. So that's first. So we've got that one done. All right. Which one would you say was next? Remembering, once again, I think we only have one other negative number though. So the next one would be what? Yes, the negative 4.472. Good job. Which was the negative square root of 20. So that was next. And then the next one is, I should have put spaces in between those numbers. Sorry. The next one is, can you still read it okay? The next one in our list is what? After the negative. Yes, good job. It's 0. Perfect. You're rocking this. And then the next one would be what? After the 0 would be what? Yes, good job. Good job. And the 2.646 was the square root of 7, correct? Okay, so we put down the square root of 7. And then the next one is what? 4.1. That was given, right? Yeah, that was given. And then the very last one is what? I think we only had one left. Yep. Good job. You ordered those perfectly. So does that make sense to you? Basically, converting everything to a decimal when you're ordering numbers, you're converting everything to a decimal. And then the other thing that we needed to do was talk about whether each individual number was a real number, was rational, was irrational, an integer, or a whole number. And that's a mouthful. So let's go through each one and kind of talk about it. The negative 9/2. All of these are real numbers. Oh, okay. In about 5 to 10 minutes. Yeah, I remember. I think you usually have an appointment about this time. So yeah, that's cool. And sorry I was late. I had internet problems, so I'm sorry about that. I appreciate you. I appreciate you always showing up. Let's see. Negative 9/2 is a real number. It's also a rational number because it's not a repeating decimal. It can, that's what makes it, or actually not a repeating. And it is either a number that can be expressed with one number over another, and it's a repeating decimal. I'm going to get it right in a minute. A repeating decimal is actually a rational number, like 0.33333 is a rational number. A decimal that goes on forever and ever and ever and ever and ever, like pi, that's an irrational number. And oftentimes those square roots, those weird square roots like pi, are going to be those irrational numbers. Kind of giving you a heads up about that. So negative 9/2 is a real number, and it's a rational number because it's a decimal that ends. It either terminates or repeats. That's what I was trying to say earlier. I'm sorry, I was up a late last night. My daughter lives in Florida, Sarasota, Florida, and she's driving here for the hurricane, and she was kind of trapped in Florida. So I was up all night worrying. So I'm a little scattered this morning. So forgive me. Yeah, I was a little scared, but now I know. She traveled. Her friends were in another car, but they were traveling north too, and there were no hotels. But they parked next to each other, in a rest area, which is why I was so frightened. But they were right next to each other. Praise God. And let's see. I'm not absolutely positive. Hey, baby, do you know when the hurricane's supposed to hit? Is it this weekend?
Yeah.
Yeah, this weekend at some point. But she lives 3 minutes from the beach. And so they were trying to start the evacuation process a little earlier because of all of the people that unfortunately perished in Texas in the evacuation process. So I guess my daughter told me about 30 of the people that died were actually in the process of evacuating. So that's why she was a little scared. So this mama was up all night. So if my words are, oh yeah, me too. Me too. That's where my prayer is this morning for sure, Evan. But so if I sound a little scattered, that's why. Thank you for putting up with me. Yes. Oh, thank you. But anyway, back to math. Over the hurricane, back to math, I guess. And then let's see, what was our next one? Our next one, where we put them in order, was the negative square root of 20. And the negative square root of 20 is a real number, as all of these that we're dealing with are. You're really not going to deal with non-real numbers until Algebra 2. So all of these are real numbers, but the negative square root of 20 is an irrational number because it was when we calculated it on our calculators. Remember, that was one of the ones that we actually we had to kind of terminate the decimal to put it on our paper. We did the terminating ourselves, but actually in the calculator, if you were to keep doing it, it would go on and on and on forever and ever, much like pi. Yes, good job. Yeah, thank you for putting that up there. So that's what makes it irrational. Oh, I like the arrow. Good use of the arrow, Evan. I don't think I've ever seen that before. Where'd you find that? Oh, you did some dashes in the little thingy. Smart. I learned something new. Thank you. Way to go. Way to help the teacher with the keyboard. And okay, so then what was our next one in order? It was a 0, no explanation there. 0 is actually a real number and a rational number. It's actually an integer. Also, do you remember integers from previous years, where an integer is just like, it's what we call just your whole numbers, like 0, 1, 2, 3, 4, and then negative numbers, but they're all whole numbers, no fractions. It's the ones we all like best. They're the pretty numbers. So 0 is a real number, a rational number, integer, and it actually falls into what we call whole numbers, because whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8. And then like our counting numbers, that kind of thing. So it's a whole number also. And then after 0, we had the square root of 7. So it's a real number, and it's an irrational number because it had the behind the decimal point continued on and on, like your fancy little arrow thing showed me earlier. And then what was the very last? Oh, the next two are 4.1 and 5.2. The 4.1 is a real number and a rational number, and the 5.2 is a real number and a rational number because they are terminating decimals. These are just all how we group numbers. I hope, did that clarify how numbers are grouped? And do you think that would be a good thing for me to go back over in class? Do you think people remember how numbers are grouped? Like, did you see, do you have your book by chance in front of you? 2? If not, I'll just bring it. Okay, let me just go up here and do this then. This beautiful little chart right here. Let me go back to the Google Hangout, see what you're seeing. That way I can see what you're seeing. But that, the set of real numbers is the set of all rational and irrational numbers. So that's like everything. And like I said, you won't really get to non-real numbers. They're actually called imaginary numbers. Believe it or not, just when you thought numbers would get confusing, 2 years from now, you're going to learn about imaginary numbers. It's not too bad. I promise. You'll be ready. You're smart. You'll get it. My middle daughter just screamed from the background. I don't know if you heard her. She said that's what they always say. She didn't like imaginary numbers, but you'll be fine. Mackenzie liked them. So the set of real numbers, and then within the rational numbers, you've got some subsets, or the 2 subsets of real numbers are rational numbers and irrational numbers. And then within the subset of rational numbers, you've got integers, which are like all of your whole numbers, and your negative numbers, your integers, which are negative numbers, and all of your whole numbers. And then whole numbers start with 0 and go forward and contain all your positive numbers. So that's a really good chart to kind of, was that in the video? That chart? If not, I probably need to make copies of that and hand that out so that y'all can kind of, oh, okay. I need to make sure that if you don't have it, that I go ahead and make a copy of it so that y'all can put it in your math composition books. Just because a good visual on that to be able to clarify and do all of the homework is going to be really helpful. I don't think I have too many problems where you have to actually classify the numbers, but this is important because later on in different math settings, you're going to have to group and subgroup the numbers. And this probably is the most, I don't know, intense part of this 2.1 lesson is actually grouping the numbers. Do you have any particular questions for me? Okay. Well, I know that you have to go fairly soon for your appointment, but I appreciate you always showing up. Oh, good. Good. And then and always putting up with my household, and oh, good. I'm so glad. I'm very, very glad. And I hope you've been getting some pointers on things. And oh, good. I wanted to. Did I give you your grade? I'm going to type your grade. No, I won't do that because it's still public. But you did well on your test. I wanted you to know. So I was really, really proud of you, and you did really well on your classwork too. Now I'm looking for it now. I can't find it, but I'll are you sure? It's public and recorded. I mean, it's not anything to be embarrassed of. I'm kind of sensitive about, yes, I'm kind of sensitive about private matters, even when it's good. Oh, yeah. Only for Cornerstone. It's a YouTube thing, but it's only for Cornerstone website. So that way, if someone, that's why it's like, if someone can't make it to Math Lab, and I haven't quite figured out how to show people where the link is yet. But I can go back. I can actually, if you want me to, tomorrow, if you remind me in class on Friday, I will show you where it is, like how you can get to it. Because I can go back on my YouTube channel, because believe it or not, they make the math teachers who do Math Lab get a YouTube channel. How awkward. But I can show you on my YouTube channel where we can watch it. You can see us. I don't think the chat window comes up. That'd be interesting. I'd be curious to see if it comes up. So I'll have to go back and watch that. I haven't watched one in a while. Let me see. I grabbed the wrong red folder. Yeah, I could email you your test grade, but it was good. It was real good, and you get points for coming to Math Lab. Because I don't think you have ever missed, have you? I think you even logged on one day to, I was going to say, I felt like one day you logged on to tell me you couldn't be there. I was like, that's impressive. I know. So, I think I've about covered all of the lessons. I can't think of anything else to cover with regard to everything in this particular chapter that we're going to be going over tomorrow in class. I haven't even looked at the classwork. I guess we could have started on that too. I don't know if you have time now. Do you? Oh, okay. Oh, no problem. No problem. It's not a whole lot of classwork. I think you'll probably finish in class tomorrow. Do you have a math study hall too? Or a study hall, either one? Okay. All right. So, well, next time when it's a short one like this, okay, I'll just try to make sure that we get started on the classwork as well, so that you'll have some additional clear, to get started. You might be bored in class though. So I hope you have a wonderful day. Take care. I'm probably going to sit here and see if anybody else shows up, because I was late for showing up because of the internet here. The other day, the electricity went out at our house, so I had to reboot we had to reboot our router. And okay, see you tomorrow.